So, good morning, one and all. Today we can discuss of the earlier program, earlier topic, harmonic functions. I already written here. Harmonic functions we are telling today. The two-dimensional Laplace, the two-dimensional Laplace equations here. You know that dou square phi by dou x square, dou square phi by dou y square is equal to 0. This is the Laplace equation. The function of phi of xy and we are taking here. So you see here the dou square phi by dou x square, dou square phi by dou y square is equal to 0. We are taking here. But even though in the function phi of x comma y we are taking here an important potential theory, this is the application particular to the fluid dynamics. The function I am writing here u is equal to f is equal to u plus iv. This is imaginary and real and imaginary part. U plus iv is analytic in a region. U and V is satisfy the above partial differential equation as satisfy partial Riemann equation also. We are taking U and V are used here. So any one definition we are taking in this point of view. One definition we are taking here. Any function satisfying that e dou square phi by dou x square plus dou square phi by dou y square is equal to 0 set to the harmonic or potential function. That is the one thing we are taking. And you place one theorem you have to learn for this one theorem. If f is equal to u plus iv is analytic in a region R, then u and v are harmonic. Already told harmonic dou square phi by dou x square plus dou square phi by dou y square. Already told u are v and r harmonic in R, capital R, if they have continuous second partial derivatives. What is the second partial derivative, sir? Second partial means first derivative f dash, second derivative is f double dash. Second partial derivatives in derivatives in R. So we are thinking here, u plus I, you know the real and imaginary part in a region of R. U and V are harmonic functions. The continuous second partial derivatives we are finding here. So therefore, we can take in here. So see here. So therefore, we have take this one proof here. If f of z we are taking here is analytic. F of z is analytic function. Analytic in R, we know the Cauchy-Riemann equation. Cauchy-Riemann equation, we know that. Cauchy-Riemann equation, we know that here. So that is what is that? The dou u by dou x is equal to dou u by dou y. So dou u by dou x and dou v by dou y, this is taking here. But even though the second condition is dou v by dou x is equal to minus dou u by dx. I already told in the yesterday's class also, dou u by dou x is equal to dou v by dou y, dou v by dou x is equal to minus dou u by dou y are satisfied in R. Are satisfied in R. So therefore, let u and v are continuous second partial derivatives are in R we are taking here. The differentiative of both sides with respect to the x and with respect to y. So with respect to the x and with respect to y, both are we are taking here. So dou square u by dou x square. That is dou square v by dou x dou y. So why? Because with respect to the x, therefore dou x dou y. So here in the second one, dou square v by dou x, dou y dou x. I'm adding with respect to y. So dou u by dou y square. So this is the dou square v by dou square u by dou y dou x minus dou u by dou y square. So there square u is common here. See here, this is dou square u by, see here, dou square u by dou x square. This is dou u by dou y square. This is dou square v by dou x dou y, dou square v by dou x dou y. So equal the same. U is the function of dou y square. So from which we have to see here. We can see that here dou square u by dou x square, that is minus dou square u by dou y square, or we are writing here dou square u by dou x square is come to this side. This is plus dou square u by dou y square is equal to 0. So that is the u is a harmonic we are taking here. So similarly differentiating on both sides of the with respect to x and with respect to y. So therefore we have to write also this one dou square v by dou x square and the dou square v by dou y square also is equal to 0. So therefore v is harmonic also we are telling that. V is harmonic also we can doing here. Then one definition. One definition is if two harmonic functions, ux comma y and vx comma y, ux comma and vx comma y satisfies the Cauchy-Riemann equation, satisfy the Cauchy-Riemann equations. So ux comma y and vx comma y satisfy the Cauchy-Riemann equations. So therefore dou u by dou x is equal to dou v by dou y. And dou u by dou y is equal to minus dou v by dou x. See here, this is a very difference. Cauchy-Riemann equation dou u by dou x equal to dou v by dou y. Dou v by dou y minus dou u by dou y minus v is said to be the conjugative harmonic function of u. So under this, so u is evidently is conjugative function of harmonic function of v of here. So one theorem you have to learn here. So one theorem, let the region be either, let the region be either the whole plane C, the whole plane C, or some open disk we are taking here. If u r stands to r we are taking here is a harmonic function. Then u has a harmonic conjugate. See here, let us the region of either whole plane C or same open disk U R to R is a harmonic function. Then you has a harmonic U has a harmonic conjugate. So proof there. In this proof we are taking here. So there are no laws of generality in the region what we are taking, the region R we are taking here. The open disk with origin of center and the radius we are taking here. Radius R greater than 0 here. It is true for every open disk, that's the whole plane, in the whole plane. But our aim here to find harmonic function. What is the harmonic function? V of x comma y we are taking here, and also such that u of x comma y both are taking here. So such that u comma x comma y and v comma x comma y satisfy the Cauchy-Riemann equation. We know that dou u by dou x dou is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. We can take the Cauchy-Riemann equation. Let us we have to define here. V of x comma y I am taking here. Integration of 0 to v dou u by dou x comma t into dt minus integration of x dou u by dou x comma 0 ds. So what is x comma t? I'm taking here 0 to y means x comma t and s comma 0. I'm taking here into first one with reference of t dt with reference of this one is 0 to x. X, therefore dou u by dou x S0 of dx. So I'm taking the integration of these both ones taking here. So that I'm taking here dou v by dou x comma y. Therefore, integration of y I'm taking here dou square u by dou x square. Second derivation I'm taking integration I'm taking here dou square u by dou x square of x comma t into dt minus the dou u by dou y x comma 0. So dou u by dou y I'm taking here integration 1. So that is the integration of x by 0. So again integration of 0 to y I am taking here. So therefore minus dou square u I'm taking here. We have to write minus dou square u by dou y square x comma t I'm taking here into dt. So the second derivation. So dou u by dou y x comma 0 I'm taking here. So therefore minus dou u by dou y that is x comma t. So the simplification of the integration and substituting here plus dou u by dou t plus dou u by dou t x comma 0 then minus of dou u by dou y dou u by dou y x comma 0. So therefore after the simplification minus dou u by dou y x comma y I'm writing here minus dou u by dou y. So similarly we have taken minus dou u by dou y x comma y also we are taking here. So similarly we are taking here dou v by dou y x comma y is equal to dou u by dou x x comma so both are this is v this is u so both are we are taking similarly. So u comma x comma y and v x comma y satisfies the Cauchy-Riemann equations here. So u of x man u of x comma y being harmonic, v of x y also is harmonic, but then v of x y is harmonic conjugate of v of x y. This is the fundamental formula. This one. Suppose one problem we have to do here. Problem one we have taken here. If f of z I am taking here, u plus iv I am taking here, is u plus iv is analytic function and z is equal to r cos theta plus I sin theta. That is equal to r sin theta plus cos theta plus sin theta we can write here e power I theta. Cos theta plus I sin theta we are writing here e power I theta. Where we are taking it is a function. This is the problem u comma b comma r comma theta dou u by dou r is equal to 1 by r into dou v by dou theta comma dou v by dou r is equal to minus 1 by r dou u by dou theta. Dou theta. So this is a fundamental. What is the given the problem here? I will explain this problem here. Since we are taking here proof, since f of z I am taking here u plus iv, we know that analytic function. U plus iv is analytic function. The Cauchy-Riemann equation, we know that dou u by dou x is equal to dou v by dou y. And also dou u by dou y, u minus dou v by dou x. Y comes to the dou u by dou y, dou v by dou x, but are satisfied in the but z is equal to we know that in the real and imaginary part x plus I. So therefore we are taking here x is equal to r cos theta, y is equal to r sin theta. We know that in the problem they're given that z is equal to r into cos theta plus I sin theta. So z is equal to r cos theta plus y is equal to r sin theta I am taking here. So r into cos theta plus r into sin theta I is the imaginary part. So therefore that r is equal to I am taking here under root of x square plus y square. Formula is theta is equal to tan inverse of y by x. R into e power I theta we taken, theta is equal to tan inverse of y by x. Then we have taken here dou u by dou x we are taking here. So dou u by dou r into dou r by dou x. So see here dou r by dou r, both the dou r by dou r cancel, dou u by dou x and in plus dou u by dou theta into dou theta by dou x. So we are finding these values here. So is equal to dou u by dou r. So what is dou r by dou x? R is equal to what we have taken here with respect to x dou r by dou x. See here, this is our dou r by dou x. So this is dou r by dou x means r x cos theta. So x r is equal to r is equal to what we have taken in under root of under root of x square plus y square. So therefore, the square will be that will be removed here. X is x by under root of x square plus y square we have written here. So plus dou u by dou theta also same here. This is minus of y by under root of x square plus y square. I'm simplifying this under root of x square plus y square. I'm writing this derivation. So therefore, dou u by dou r into cos theta. What is the cos theta is equal to x by r. R means what is here? X by r is equal to what is the cos theta. So what is r value here? R is equal to under root of x by x square plus y square. So under root of x square plus so x by under root of x square plus y square is equal. So x by under root of r means x square plus y square. So therefore, what we are writing here cos theta. So that is a fundamental right. I am writing here cos theta. Then minus 1 by r. Again minus y కాబట్టి we have to do u by dou theta into sin theta we are writing here. And so therefore, the fundamental value I'm writing here. So therefore, dou u by dou y, because again I'm y function taking here, dou u by dou r into dou r by dou y, plus dou u by dou theta into dou theta by dou y. So this is simplification of dou u by dou r. Then again that y by under root of x square plus y square again. I'm simplifying the above equation on under root of x square plus y square. Plus dou u by dou theta, that is x by under root of x square plus y square I'm doing. So therefore dou u by dou r sin theta plus 1 by r dou u by dou theta into cos theta. So dou u by dou r sin theta plus 1 by dou u by dou theta into sin theta. Similarly, we have also know that similarly you have to take that here dou v by dou x also we have taken here. Similarly, we are taking here dou v by dou x. That is dou v by dou r. So dou r by dou x plus dou v by dou theta into dou theta by dou x. So dou v by dou x and dou v by dou x. So therefore is equal to the simplification because dou v by dou r. Again, I am simplifying the above one. 1 by r dou v by dou theta into sin theta of the earlier one. So this one I am simplifying again here. Dou v by dou y minus is equal to dou v by dou r. So dou v by dou y is equal to dou v by dou r. Of earlier I told you here dou v by dou y, dou v by dou r. Both are equal here. So therefore is equal to dou v by dou r sin theta, dou v by dou r sin theta plus 1 by r dou v by dou theta. Dou v by dou theta cos theta. Dou v by dou theta cos theta. So and this one 1 by r, that's why it goes to minus dou v by dou theta sin theta. Cos theta will get the minus bit goes to the plus. Again here minus 1 by r dou by dou theta sin theta in the first equation. Minus 1 by r dou u by dou theta into cos theta. So that value we come to the left side, that is the plus we have to write in here. Then from the Cauchy-Riemann equation, from the Cauchy-Riemann equation, dou u by dou x is equal to dou v by dou y. We know that the value of we have dou u by dou r. So dou u by dou r, here given in the earlier problem we are given here dou u by dou r minus 1 by r dou v by dou theta. So dou u by dou r minus 1 by v dou theta in the earlier equation given here 1 by r dou v by dou theta, the earlier one given here. This is a common I am taking here. This is a cos theta minus here also dou v by dou r plus 1 by r dou u by dou theta, dou u by dou theta into sin theta is equal to 0. This is the taking of the common here. So this is the sin theta is equal to 0 we are taking here. From the Cauchy-Riemann equation, again you know that dou u by dou y is equal to From the Cauchy-Riemann equation, we know that dou u by dou y is equal to dou v by dou x. So therefore, again I am simplifying this one. Dou u by dou r minus dou v by dou theta into sin theta. This is the first equation part. This is the second equation. Similarly, we are taking that one. So this one I am taking here minus dou v by dou r plus 1 by r dou u by dou theta into cos theta is equal to 0. This is equation 2. So multiply equation 1, the above one, first equation multiplying by the minus cos theta, first equation multiplying with cos theta, second equation with sin theta, multiplying with sin theta, and adding the yields we are taking here, and adding yields also we are taking here. So therefore dou u by dou r minus 1 by r dou v by dou theta. So cos theta, first equation cos theta, sin theta into cos theta into sin theta is equal to 0. So multiplying by cos theta and also by sin theta, so is equal to 1 by 1 dou u by d is equal to 0. Dou u by dou r is equal to 1 by r dou v by dou theta. And the second is multiplying the second equation, multiplying 1 by minus sin theta, from multiplying with the cos theta, adding the yields we are taking here. So therefore, the second equation, dou v by dou r plus 1 by r dou u by dou theta is equal to 0. Well, here multiplying here by minus sin theta and second by cos theta, adding by yields we are taking here, adding by yields we are writing here 0. So therefore dou v by dou r is equal to minus 1 by r dou u by dou theta. Here we are taking here minus 1. Here also this is that side goes to plus 1 by r dou v by dou theta. So what we have proved here, Cauchy-Riemann equations taking here, and the chain rule taking here, and root of here. So therefore, x square and root of x square plus y square, the both the applying the rules and we are multiplying the same, and we are finding the equation from one and two here. Another problem we have to take here. U is equal to e power x sin y minus y cos y. X sin y minus y cos y is harmonic. Then second one, find v. F of z is equal to u plus I v. Analyze it. Analyze. F of u plus I v is analyzing this equation here. Replace I v is analyzed. So what is the here? First we have to e power x xy is x sin y minus y cos y is harmonic. How is the harmonic? We have to tell the first one. So see here in the first one. In the first one here, so it is verified that those square u by those square. So first of all, one e power. So those square dou u by dou x, first we have to find out. And those square, first what we have to dou u by dou x. So see here dou u by dou x with respect to x. So what we are finding here, we dou u by dou x, e power x sin y minus e power sin y minus 1 e power x sin y. So but dou square u by directly dou square u by dou x square, what we have to do? Minus 2 into e power x sin y plus x into e power x sin y minus y into e power x cos y. This is dou square u by dou y square also we are taking here. Minus x into e power x sin y. That is the first one I am taking here. Plus into 2 into e power x sin y plus y into e power x minus cos y. The first and second is adding 1 and 2 we have to take here. See here. Here. This is minus 2x minus x plus minus y into e plus xe xe. So we can write dou square u by dou x square dou square u by dou y square is equal to 0. So therefore 0 in the harmonic function also we know that dou square phi by dou square phi by dou y square is equal to 0. The condition is same, dou square u by dou x square. So dou square u by dou y square also is 0. First, we have to find those dou u by dou x, and again, we have to find that those dou u by dou x. So then we can find the then find from the Cauchy-Riemann equation the second one, f of z is equal to u plus I is analytical. So therefore, dou v by dou y is equal to dou u by dou x. So dou u by dou x is equal to what is the dou u by dou x? E power x sin y. First I'm finding it e power x sin y minus x into e power x sin y plus y into e power minus x cos y. E power x sin y. So e power x sin y means x is the I'm multiplying it e power x sin y. Then exact x into e power x sin y plus y into e power x cos y. I'm multiplying the same here for the chain rule. Dou v by dou x is equal to minus dou u by dou y is equal to e power x cos y minus x into e power x cos y minus y into e power x sin y. So e power x cos y minus x into e power x cos y. So I'm taking these values of this order. And then fourth, integrating with respect to the third equation, keeping x as constant here, therefore v is equal to minus e power into x cos y minus into e power x of cos y. So v is equal to plus x into e power x cos y, we know that, plus e power x, I'm taking the common one, y sin y into y sin y plus cos y. Plus the common of this is I'm taking f of x. So therefore we have to write here y into e power x sin y plus x into e power x cos y, y into e power x sin y. I'm taking this above one simplifying here. So it's f of x. So f of x is a real root. So what is f of x? The real function of x. So this is the equation of 5 I'm taking here. So then we have to get here. So then we then get here minus of y into e power x sin y minus of x into e power x cos y plus e power x cos y plus f dash x we are taking here. Then minus y into e power x sin y minus x into e power x cos y plus e power x cos y. So I'm taking the simplification of the above both the values minus e power x into cos y and minus e power x into cos y plus x into e power x cos y. So I'm the minus y into e power x I'm simplifying here. So therefore this leads here. So therefore this leads here. F dash x is equal to 0. What is f dash x is equal to 0? Automatically we know that a is a constant. A is a constant means f of x is equal to c. We are writing here. So now choose the c is equal to 0. So b is equal to now 5 fifth equation becomes here. B is equal to y y sin y plus x cos y. So the fifth equation becomes this one. But even though we have taken here, but even though we are taking here, but y sin x plus x cos y we are taking here, so that we are applying this one. We know that f of z is equal to e plus iv. What is that? I'm writing the value e of x, u value I'm writing x sin y minus y cos y. This is the u value plus I into e power minus x y sin y plus x cos y. This is the value of this one. E power x, I'm taking the common here. X is a y, x is sin y, this is x is sin y here. So therefore, x into simplifying here, e power iy minus e power minus iy by 2 sin I in the hyperbolic formula we are writing here. Hyperbolic function like of e power iy plus e power of minus iy by 2 we are taking here. I into e power x, e power iy minus e power I minus I by 2i plus x into e power iy plus into e power minus iy by 2. So e power iy అంటే iy means cos. This is sine. E power iy plus e power I minus iy is the sine, and this is minus is sine, plus is cos. Minus is the sine, plus is cos on the hyperbolic functions. I'm taking the values here. So right then I of x plus iy. All these functions are we are taking x plus iy. E of x minus iy. So I'm simplifying to the imaginary part. This is the e power x, which is right. Yeah. Next one. So, yeah. U is equal to x square minus y square. V is equal to y by x square plus y square. U of x, v equal to minus x square plus y square. Therefore, x square plus y square is not equal to 0 here. So by x square plus y square not equal to 0, is equal to 0, the value is 0 here. So then show that both u and v satisfy the Laplace equation. But u plus y is not an analytic function. But u plus I is not an analytic function. U plus I is not an analytic function. That is equal to x plus I by we are taking here. First we are taking dou u by dou x. So dou u by dou x is dou by dou x x square minus y square. So we are taking partial derivation x, y is 0 is equal to 2x. Dou v by dou y. So dou v by dou y means we have taken here the u plus v method. So dou v by dou y we are taking here the y function, v function we are taking. So u by v method is there, u by v method is there. So x square plus y square minus it is taking here. So therefore you divide u into divide x of v into divide x of by v square. So we are simplifying here. So therefore x square plus y square, and again the constant here. Therefore we are writing here directly here, u into d by dx of v minus v into d by dx of u by v square. So what is u here? Minus y dou by dou x of x, just a minute. So therefore dou by dou u by dou x of x square plus y square. Then minus of x square plus y square into dou by dou x of u means u means minus y. So therefore here x square plus y square whole square. This is x, y, this is totally 0. This is totally 0. Dou x square plus y square dou by dou x means y 0. The constant something is 0. So again we are taking here minus of y. Dou by dou x of x square means dou by dou x of x square. Dou by dou x of x square. So therefore we are writing here to x square plus y square. X means y square is 0. So therefore we are simplification here x square minus y square. Then x square plus y square. We are writing the simplification here. Again, same I am writing dou u by dou y is equal to minus 2y. Dou v by dou x is equal to also 2x by x square plus y square whole square. Automatically dou v by dou x we have to equal. But x square plus y square also not equal to 0. But dou u by dou x is what is the value x square minus y square by x square plus y square whole square. Dou v by dou y, dou u by dou y. So dou v by dou y. So evidently we are taking here. So dou u by dou x not equal to dou v by dou y. Dou u by dou y not equal to dou v by dou x minus. So both values are now by dou u by dou x equal to x. Dou v by dou y. What is dou v by dou y? X square minus y square. That is of x square plus y. So both the values are not same. We are finding the above here the values here. But evidently we are seeing here. But therefore U plus IV, we know that is not analytic function. U plus IV is not analytic function we are taking here. So those square our harmonic function, we know that rho square U by dou x square, rho square U by dou y square is equal to 0. So now I am applying here the values here. Rho square U by dou x square, rho square U by dou y square is equal to 2y. I'm taking here. I'm simplifying above the values of y square minus 3x square by x square plus y square whole cube. The third party plus 3x square minus y square by, I'm simplified here, x square plus y square whole cube into 2y is equal to 0. 2y is equal to 0. I'm taking 2. So this is the value of this one. This is the z equal to x plus I. What the fundamental we have taken. Another one also we have taken here. So by using the Cauchy-Riemann equation, show by using the Cauchy-Riemann equation that F is analytic and the region R and its imaginary part B is constant, then F is constant. Then F is constant. So what is the Cauchy-Riemann equation? Dou by dou x equal to dou v by dou x. Dou v by dou y equal minus dou v by x. So dou v by the Cauchy-Riemann equation, we know that dou v by dou v by dou u by dou y equal to minus dou v by dou x, dou v by dou x equal to dou v by dou y. We are taking here the Cauchy-Riemann equation. So therefore, suppose that we know that u plus I am taking it here. Suppose we are taking the truth. X is equal to u plus I, we are taking here. So dou v by dou x is equal to x comma y. So dou v by dou y is equal to x comma y. So this is x function, this is y function, both are values are 0. For all x comma y, such that x plus iy belongs to x. The Cauchy-Riemann equation, we know that x plus iy we are taking here dou u by dou x, that is x comma y, plus I into dou v by dou x comma y we are taking here. Then dou v by dou y, x comma y, plus I into dou v by dou x comma y. So both the values are 0. So dou v, dou u by dou x comma y, I imaginary part dou v by dou x, and dou v by dou y, and dou v by dou x. See here, this is dou u by dou x, this is dou v by dou y. But here dou v by dou x, here dou v by dou y. Dou u by dou x, dou v by dou x. So all these values we have taken here, the value is 0 here. This is the value. So at least this is dou u by dou y. So the function at least constant also. So that one another problem we have to learn here. So that f is a function, f is a several value analytical region on them. So that f is that if a function f is a real value analytic on a region or then it is constant on. So then it is constant on. See here, so f is a real value, so f is a real value than r. So then the imaginary part of it, then the real value is r, we know that. But imaginary part of it is constant. We know that imaginary part is constant. Why? Because the namely we can take that as 0. So from which f is analytical on. So therefore the constant on r also we are taking here. And another one problem we have to learn here. so that we define a function expressed by the form z is equal to under root of xy into minus under root of xy if xy less than or equal to 0, if xy less than 0, where z is equal to x plus iy in the real and imaginary form. So in the real and the imaginary part of what satisfies the Cauchy-Riemann equation. Cauchy-Riemann equation. That is 0 is equal to 0, comma 0. But it is not differentiable. It is not differentiable. So it is not differentiable here. Okay. So what is here? The real and imaginary parts f of the real and imaginary parts f of we have to know that proof the real and imaginary parts of f of ux comma y is equal to root of xy xy greater than or equal to 0. 0 is xy less than 0. So root of xy is greater than or equal to 0, 0 xy less than 0. So root of xy 0. So if xy greater than 0, if xy less than 0 here, then v of x comma y I'm taking here 0 in the root of x minus y, xy greater than or equal to 0, xy less than 0. So therefore we are taking here, so dou u by dou x, dou u by dou y, so therefore dou u by dou y is equal to 0. So therefore limit x tends to 0. We know that u h comma 0 and u 0 comma 0, given the values here 0 comma 0 h. So limit x tends to 0, I'm applying here. Limit 0 minus 0 by h is equal to what is the value? 0. Similarly, for same, dou u by dou y 0 comma 0, then dou v by dou x that is 0 comma 0, that is same dou v by dou y also 0 comma 0, that is equal to applying the same values here. So Cauchy-Riemann equation satisfied under the condition of 0 comma 0. But the f is not differentiable. So we should now we can prove that here or show that here f is not differentiable at 0. How is it not differentiable? We have to see here f of x minus f naught by h we are taking here alpha square by alpha plus I alpha, that is 0. X is equal to alpha plus I alpha, alpha not equal to 0. If x is either real or imaginary, and x not equal to 0. H is equal to I plus alpha plus x is equal to alpha plus I alpha, but x is either real or imaginary and x not equal to 0. So therefore, f of x minus f naught by h. So therefore, modulus alpha by alpha into 1 by 1 plus I, if x is equal to alpha plus I alpha sin alpha not equal to 0, alpha plus I alpha sin alpha is equal to 0, 0 if x is either Real or imaginary. But h is either real or imaginary, but we are taking, but h not equal to 0. Why? Because h is equal to 0, there is nothing. H is equal to 0. H not equal to 0, then only we have to solve the problem. So since any open disk we are taking here, and center data 0 contains numbers. So from the contain numbers alpha plus I alpha greater than 0, and with alpha less than 0, alpha greater than 0 or alpha less than 0, f of h minus f of 0 by h. So 1 by 1 plus I, h is equal, we are taking I plus alpha plus I alpha, and alpha greater than 0 we are taking here. Minus 1 by 1 plus I taking h is equal alpha plus I alpha less than 0. Minus means less than 0. Positive means greater than 0. 0 means h not equal to 0, we know that. And h is either real or imaginary. Either h is either real or imaginary. So we are taking h is real or imaginary function taking here. So f is not, how it is differentiable? It is not differentiable. Directly we are taking substituting the values is 0. F is not differentiable 0. It is easy to convenience that the partial derivatives when we are not continuous at 0, comma 0. So not continuous at 0, comma 0 we are taking here. So some more problems here you have to do. And the elementary functions we have another chapter we have to learn. Elementary functions. So in the elementary function, exponential function we have learned, trigonometric functions, hyperbolic functions, logarithmic power functions also we have taken here. So in this unit, define exponential functions and identify the differential functions of the real function. Differential complex and the real complex exponential functions we are learning here. Define the trigonometric and hyperbolic functions and properties, logarithmic functions, and difference between the logarithmic functions, arguments, and functions we are learning in this elementary functions. In the elementary functions, what is the exponential function we are learning? What is exponential function? So the exponential function is what we have to take e power. It's the basic of importance of the complex analysis. So one other elementary transcendental functions, the motivations being the exponential function of the complex variable, two principal properties of the real. What we have to write here, exponential function x1 plus x2 that is equal to exponential of x1 into x. The addition should be multiplication exponential of x2. Then d by dx, the first derivative of exponential of x is exponential of x. So d by dx of e power x is e power x. There is no change of exponential function here. So in the multiplication of also, in the addition also, we are taking the multiplication exponential function, x1 into exponential function. So we have to find one definition here. The exponential function exponential of a complex variable that is defined by exponential z is equal to e power x cos y plus I sin y, where z is equal to x plus I sin y. Exponential z is equal to e power x plus cos y plus I sin y. So z is equal to x plus I, we know the real and imaginary part we have taken. So e power x or exponential x or cos y we are taking here, or sin y. Cos y or sin y are the usual exponential trigonometric functions. We use the notation e power x or for exponential of z. So we shall use the exponential for the name of the function e power z, its value also we are taking here. Properties of exponential function. What is the property? Properties of exponential. Properties of exponential function. The first one, e power 0 is equal to 1. We know that e power z1 plus e power z. We have to write e power z1 into e power z2. This is a multiplication. The second condition, modulus of e power z also e power z minus also value minus the modulus it should be positive. In cos y plus I sin y, this is the value is 1. E power z is not 0. E power z is not 0 for any z. Modulus of e power z modulus of e power z e power x. So e power z is e power x, but e power x can never be 0. Can never be 0. Then fourth one, 1 by e power z equal, we can write 1 by e power minus z. The e power z, we have to 1 by e power minus z. So e power minus z into e power minus z into e power z. So that is 1 by e power minus z into e power z is equal to 0. So e power 0 is equal to 1. We have know that. Then the condition, e power z the whole power n, e power nz, multiplying with the same. 2 e power 2 into 3 is 2, not 2 cube. 2 into 3 means 6. E into 3 into 2. 2 cube whole power 2. That is 3 into 2, 6. We have to write here. That is also we have e power n into z. So that is also e power z into e power n. So e power, so for e power n into z, e power z into n. So another one, e power z square, I already told. E power z into e power square. So e power 2x into cos y plus sin y whole square. E power 2x cos 2y plus I sin 2y. That is equal to e power 2x here. The general the general result can be proposed in introduction of n is the positive integer. So the property of even when n is a negative integer, u e power of minus I5 is equal to minus 1. E power of 2I5 is equal to 1. I5 is minus 1, 2 pi is 1 is the negative. This is 1. So therefore, we can see significant difference between two complex numbers and the real exponential function also we are taking here. The real exponential function one is 1 to 1, but since e power 2 pi is equal to 1, e power 2 pi is equal to 1, that is equal to e power 0. Complex composition is not 1 to 1, it is the periodic. It is periodic. Another one definition you will learn here. A complex function f is periodic if there is non-zero complex number is such that f of z plus t, we are writing here f of z for all for all z is here. So the number p is set to be the period of it. The number is p set to the period of f here. So this is the periodic function of many periods. So we usually see that p is the period. So np is a non-integer. So therefore the usual situation of all the periods, the multiplies of one basic period. The exponential function of periodic non-zero integers multiplies non-zero integers multiply 2 pi I. So therefore we can take in here e power z is equal into power z into e 2 power I e power 2 pi pi, that is equal to e power z. 2 pi is the period of exponential function we are taking here. So on the other hand, t is a period. So e power z into t we are taking here. That is also e power z. That says t is a, so for all z, so the particular e power z is equal to 0. E power t is equal to also e power t is equal to e0 is equal to 1. So therefore e power z is equal to e power z I am taking here. Suppose we are taking here, suppose t is equal to alpha plus I beta. Suppose t is equal to alpha plus I beta. In the property we are taking here, e of I e power p is equal to e power p is equal to e power alpha is equal to 1. So alpha is equal to 0. So cos beta plus I sin beta is equal to 1. So beta is equal to 2n phi. So some integer p is a period. P is a period but must non-zero. So hence p is equal to 2n phi we are taking here. So n is a non-zero integer. So n is a non-zero integer we are taking here. Then the trigonometric function. So the trigonometric functions, we know our attention, the complex functions of the properties means the properties of the trigonometric function cosine and sine. What is the sine and cosine? So our definition of exponential values are real and cos and sine. In fact, we can express those functions in terms of exponential. This suggests a way of extending the trigonometric functions of the complex function. Those functions of in terms of exponential functions, this suggests a way of extending the trigonometric function of the complex function. From the definition, from the definition, from the definition we are taking of exponential, p is any real number. P is any real number we are taking here. E power I t is equal to cos t plus I sin t. So e power minus u. Minus u means cos u minus I sin. Cos t, e power cos t minus I sin t. So e power minus u also e power u is equal to cos t plus I sin t. E power minus u is equal to minus cos t. Minus I am taking here cos t minus I sin. What is the hyperbolic functions we are taking here? Cos means cos t is equal to e power u plus e power minus u by t. So therefore sin t is equal to also e power u minus e power by 2. This is hyperbolic function of sin and cos. Sin t is equal to 1 by 2 into e power u minus e power u. 1 by 2 into e power u plus e power minus 2, that is cos t. This is the defined complex cos and sin functions here in this trigonometric functions in hyperbolic. Another one definition we have to take here. The complex trigonometric function. Complex trigonometric functions, cos and sine we are taking here are defined by cos z is equal to 1 by 2 already I told, e power u plus e power e power I z we are taking minus e power I z, and sine z is equal to, you know that, 1 by 2 e power I z minus e power minus I z for all z belongs to k. For all other trigonometrical functions are defined by here we are writing here. Z is equal to sine z by cos z. Cot z is equal to 1 by tan z. So therefore tan z is equal to tan by cos z. Cot z is equal to 1 by tan z. Secant z is equal, that is 1 by cos z means it is a secant z. So cosec z means 1 by sin z. This is the fundamental properties of this one. The properties of cos and sin functions we have to learn here. Properties of cos and sin functions. Properties of cos and sin. Cos and sin are interfunctions. Cos and sin are interfunctions. Cos dash is equal to minus sin. Sin dash is equal to cos. Cos means sin, sin dash means cos we are taking here. So therefore, cos dash is equal to z we are taking 1 by 2 I into e power I z, I into e power I z. This is cos. So then is equal to, we have minus 1 by 2 pi we are writing. Why? Because 1 by 2 I am writing here. Sorry, 1 by 2 I am writing here this one. E power I z minus e power I z I am taking here. This is minus sign. This is a hyperbolic function of sine. So therefore I writing here minus sign. So therefore sin dash z I am writing here 1 by 2y I into e power I z plus I into e power I z. So 1 by 2 e power I z e power I minus I z This is cos of the function. But cos is an even function. Sin is odd and cos is even. So cos minus z of z, cos of minus z is equal to what we are writing here? Cos z. In sin is an odd function. We know that sin is odd function here. Sin of minus z is equal to minus sin z writing here. We know that sin z is equal to minus and cos z is equal to addition we are taking. We know that cos square theta plus sin square theta is equal to 1 here. So cos square z plus sin square z is equal to 1 here. But cos square z plus sin square z is equal to 1 by 4 e2 iz plus 2 plus e power minus 2 ez minus 1 by 4 e2 iz minus 2 plus e power minus 2 iz. So this is the values of minus 1 by 4 and plus 1 by 4 minus this is plus this is equal to plus 1 by 4 and minus 1 by 4. This is the cancel up. Therefore, the values are we are attaching this value, substituting these values is equal to. Then cos z plus w, cos c plus cos b, cos z plus w, cos a cos b, cos a cos b means cos z cos a cos b minus sin a sin b, sin a sin b, cos a plus b equal cos a cos b minus sin a sin b, cos z cos w sin z sin w, and sin z plus w. See here sin a plus b formula. This is sin a cos b, sin a cos b plus cos a sin b. In place of a and b, what is the value we are taking here? W and b. Z and W I'm taking here. Z and W. Z and W I'm taking here. These values I'm writing here. So therefore, in this function here, so therefore, we have to do that here cos z into cos W minus sin z into sin W. This is the not B, this is a W here. So therefore, fundamental formula I'm writing e power I z, e power minus I z, e power iw plus e power minus iw. What is this here? This is cos z. This is cos w. Cos z, cos w plus 1 by 4 e power I t sin value I'm writing minus e power minus minus into minus plus here, but plus plus e power iw minus e power minus iw. Sin a, sin z, sin w. I'm writing here. Then I'm simplifying this one. 1 by 4 e power of I z minus w. So I am taking the I am each taking the common of both the one z minus w. Here also e power of I into z minus w plus e into I minus of z minus w plus into e minus of z plus w. This is minus w z minus w plus w. Then again that we are taking here the cos 1 by 4 e power t z plus w minus e power of I z minus w. That is I'm simplifying here by above equation and psi z minus w plus e into minus I z plus w. So of the simplification here, this is also z plus w here. So after the simplification that then 1 by 2, some value should be clear here e power I z plus w plus e power minus I z plus w. So this is a plus, this is a plus number 3 cos z plus w. So cos 1 by 2 cos I power z plus w plus e power minus I z plus w by 2. By 2 means cos z plus w. Then cos z is equal to cos z is equal to sin pi by 2 minus z. Sin pi by 2 minus z I am taking here 1 by 2y exponential 1 by 5 by 2 minus z minus exponential of minus 5 pi by 2 minus z. So I'm taking this one exponential of pi into pi by 2 minus z minus of pi by 2 z. We are writing that here 1 by 2 I into e power I z minus of minus I into e power I z. So therefore this is also I power I minus I into I plus. So therefore 1 by 2 I into e power I z plus I into e power I z is just minus I z, this one is a minus I z. So this is we can write here. Cos z we have to write here. Cos z we have to write the statement here. So cos z is equal to 0 we are taking here. If and only z is equal to pi by 2, and z is equal to pi by 2 plus n pi. Wherever n is integer, sin z is equal to 0. If and only z is equal to n pi we are taking here, n is integer. The deal with sin, leaving cos for you, sin z is equal to 0. If z is e pi power z, e pi power z is equal to e pi power minus z. So if e power z 2 I z, e pi power e power 2 I z is equal to 1. So therefore, if and only 2 I z is equal to, we are taking the value of some integer of n. So sin z is equal to 0, z is equal to n I. So where n is on, integer we have to, where n is on, where n is equal to integer, we are taking here. Both, both cos and sin and divided to 2 pi, that follows from this one. This is the one of the one. And also f is a real number. F is a real number we have to take here. Cos of it is equal to cos h t. Sin of it is equal to I sin h t. Hyperbolic functions here. Cos it we have to write here 1 by 2 e t plus e power minus it. So e plus minus it we are writing hyperbolic function with cos h t. So this is the other formula proved in similar. Notice that there is a not real number than the necessary. This is what cos z less than 1. Sin z is also less than or equal to 1 we are taking it. So we know that cos h is the cos x cos hy hyperbolic function minus I sin x sin x cos h is the formula we are writing in the hyperbolic function. Minus plus sin x cos x plus plus I cos x I cos x sin x I cos x sin x we are taking it here. So this is the hyperbolic functions what we are taking here. Then hyperbolic functions. Hyperbolic function. The, com- the complex of hyperbolic functions are defined exactly the same way the real hyperbolic function. So what is the real hyperbolic functions definition we are taking here? The complex or hyperbolic functions we are taking the functions cos h and sin h. Cos h and sin h. Cos h and sin h are defined by cos h z is equal to 1 by 2 e power z plus e power z minus z. Sin h z is equal to 1 by 2 of e power z minus e power z. This is my plus. So e power z we are taking just for all complex number z belongs to C. The functions of tan h, cot h, we can take here. The cos h z is equal to also cos I z, sin h z is equal to minus I sin I z we are taking here. Properties of cos h and sin h. Properties of cos h and sin h. So cos h and sin h are entire functions here. Cos h dash is equal to sin h, sin h dash is equal to hyperbolic functions is both are positive here. Cos h is even function, sin h is odd function, you know that. Here cos sin square theta plus cos square theta 1, but here cos h square z minus sin h square z is equal to 1, sin square theta plus cos square theta 1 by the hyperbolic which is the minus. You know that the formula cos h is cos z plus w cos z cos z cos h z into cos w sin h z sin h w cos a cos b plus sin a sin b sin h z w sin h z cos h w cos h z sin h w sin a plus b formula sin a sin b plus cos a cos b cos a cos b that is also plus sin a sin b fundamental formulas you are writing here. Then cos h z is equal to 0. Z is equal to what we are writing here I pi by 2 plus n pi. Sin h z is equal to 0. Second one z is equal to n pi I. Where n is an integer. Both cos h and sin h are periodic. So we can write is the periodic equation 2 pi I we are writing here. We are writing here 2 pi I we are writing. The period of 2 I pi we are taking here. The logarithms and the power functions we are taking here. The logarithmic function, the inverse of exponential function. But in the complex analysis, exponential function is not one-to-one. We cannot state with the different logarithm. We can define the inverse of exponential function provided the domain has to make it one-to. What is one-to-one I have to replace? There are many subsets of the complex field, which is exponential one-to-one. For the moment, we restrict our attention for the region phi less than imaginary part z less than I. So we can take the imaginary part that we are taking here. Z is equal minus phi less than imaginary z less than or equal to phi we are taking here. The exponential function what we are taking here on this region 1-to-1 whole complex number w is equal to 0. For if w not equal to 0, z is equal to log of w plus I theta, where w not equal to 0 minus phi theta argument of w we are taking here. So less than or equal to 5 we are taking here argument of theta less than 2. So w is equal to e power z, we know that here. So it's the exponential function minus pi less than or imagination of z, imaginary z, imaginary z less than or equal to pi, the condition we are writing here. In inverse, the complex of the plane of the natural space minus pi less than imaginary z less than or equal to pi, the condition of the equation. So one definition we have to learn here. The exponential function is the domain. differential function. Okay, now with respect to this belongs to C, minus 5 less than imaginary equal less than 5. That belongs to minus 5 less than imaginary equal less than equal to 5 is 1 1. And inverse function is called the principal branch of the algorithm. Principal branch of the algorithm, and it is denoted by log. It is denoted by log. So minus 5 less than or equal to minus 5 less than or equal to 5 is denoted by log. We have to take in here. The log, the domain log is we are writing here. You know, Z belongs to C, Z not equal to 0. So we know the derive the formula log Z. We now derive the log Z. What is the fundamental formula? Log Z is equal to U plus IV. We are writing here. So E of log Z into the E of U cos U plus I sin V. Cos U plus I sin V. V. This is V. This is V. I sin V. Equal Z. T power of log Z. Because we are writing here small log of Z. We are writing here. So this will V of is equal to log Z. Also we are writing here. U of log U of also log Z by the real logarithm we are taking Z is equal to 0. So therefore, the requirement that we required is minus 5 less than b less than or equal to 5. This is less than or equal to 5. The principal value of the argument b is equal to argument of z is equal to argument of z. Log z is equal to log of z plus I into argument of z. We have taken. So one fundamental formula we are learning here in theorem. Log is analytic and its domain and log dash z is equal to 1. Since log is continuous everywhere in its domain, exponential dash z is exponential z. Exponential dash z exponential z is never zero. We have log dash z is equal to 1 by exponential dash log of z is equal to 1 by exponential of log of z. Also is equal to our writing here. Exponential dash log of z, 1 by exponential of log z is equal to 1 by z. As in the case of real algorithm, log does not have the property here. The log does not have the property here, but we are writing log z1 z2 is equal to log z1 in z1 plus z2. In multiplication it is plus, in plus it should be multiplication. The first lab class, many of the z1, although z1 and z2 both are domained, but log z1 and z2 may not be here in both. It may be happen all Z1 both are domain. Z1 Z2 may not. But Z1 is equal to Z2 is equal to I am taking here. But Z1 Z2 is equal to minus I. Secondly, we are taking here log Z1 plus log Z2 may not be present of the log of any complex number. So Z1 is equal to Z2 is equal to I minus 1 we are taking here. Therefore, argument of Z1, therefore argument of Z2 is equal to 3 pi by 4 I am taking here. So therefore, argument of z1 plus z2 I'm taking here. Log of z1 plus log of z2 is equal to log of 2 plus I 3 by the is the condition. You cannot be value of the log of any complex number. Here we are satisfied here. So another one we have to learn here. If none of z1 and z2 and z1 comma z2 is a non-positive, real number, then log z1 z2 we are taking here log z1 plus z2 log z1 plus the multiplication is addition here. So therefore, plus log z1 plus z2 plus 2ni 2ni 5 we are taking here. Where n is equal minus 1 0 comma 1 we are taking. So first we are taking here log z1 z2 I am taking here log z1 z2 I am taking here log z1 z2 what is log of z1 z2 the real part, imaginary part of I argument of z1 z2. So just the log of z1, just the log of z2 plus I am separating it in log z1 z2 I am separating it, then I have argument of z1, argument of z2 plus 2n. Argument of z1 and argument of z2 plus 2n. So therefore, where n we are taking here, where n can take only the value minus 1 0 or plus 1 I'm taking here. So therefore, we can write log z1 plus log z2 plus 2n we are writing here. And 5, 2n 5, 2n 5, that is only minus 1 or 0 or plus 1. These three values are taken here. So therefore, log z1 plus log z2 plus I of argument z1, I of argument z2 z. So we have pointed out the exponential function cannot have inverse, that is every domain in V, since it is not 1 1. We have constructed the inverse function and the exponential exists in the domain of the exponential to the region that is that minus 5 less than imaginary z less than or equal imaginary z less than or equal to 5. Altitude is called the principal band of logarithm. This has almost of the properties one could expect here of logarithm function. So different such regions exponentially is 1 1 here. So therefore, we can define this as the logarithm function. So we have to check the other definition here. One terminology and definition we have to take in. Region R, that is exponentially 1 1 R, but on a no region properly, containing that. So R is such that is 1 exponentially is 1 to 1 we know that, but no region properly containing R we know that is called as fundamental region. Is called as fundamental region for exponential function. So see here, R is such that the exponential 1 to 1, but I have no region of properly containing R. Fundamental region of our exponential function we are taking R. What's the terminology? In the terminology, the inverse of the restriction of the exponential fundamental region R is called branch of the logarithm. It is associated with the R and it is denoted by log R. Is a terminology by log R. So log R satisfies of exponential of log R of W. Exponential of log R W is equal to also W, and the log R W belongs to R also. We are taking here. So the domain of log R, the domain of log R is also exponential of R, that is image R and the expression is always the branch of the algorithm grows because of when you describe one mini mapping. And the algorithm may run off any mapping here. So it will rigorous analysis and divide into component functions of the parameter. So log or z also we are taking here, or it will z of 0, imaginary z relation of 2 5 also we are taking here. This image and this is called the terminology. Next class is the terminology also will continue in the definitions of this one. We'll continue the problems of that.